Hey guys, so this is all about factoring trinomials. So by the end of this module, you'll be able to factor trinomials with a leading coefficient of 1 and use that to be able to solve quadratic equations. So what is a leading coefficient? So it's the number that is in front of the variable that has the highest power of any polynomial function. So in this case, it's the value of a, because x squared is our highest power, so it's the value of a. In this module, we're just using a as 1. In our next module, a is going to be greater than 1. So we're looking at the a. And right now, it's always going to be 1. So how do we factor trinomials? First off, we need to find out what a, b, and c are. In this case, a is going to be 1. But then we find the numbers that are going to multiply to c. So we look at c and we try to find the factors of c. We then take the factors and then we add them. And when we add them, it should come up to be the value of b. And then when we find the value that adds to b, we replace the b term with those two factors. And then we factor by grouping like we did before. And then if there's an equal sign, we solve if necessary. So here's an example of this. So a equals 1, b equals 7, c equals 10. So I look at the c value and I start branching it out. In this case, 10 can be 1 times 10, 2 times 5, and that's it. So I get rid of the times, and I put a plus sign in there, because I'm adding them together. The ultimate goal is for it to equal the b term. In this case, it's the 2 plus 5. So what I do, I replace the middle term with those two terms. You'll notice that this 7x here gets broken down into 2x plus 5x. I haven't changed anything, I've just expanded it. Now I factor by grouping. I put the two terms together. The x is common, and the 5 is common in the second one. And now I can get my two parentheses. One is x plus 2. Those match up. The second one is x plus 5. The numbers on the outside of the parentheses. I have now factored that trinomial. Now, the other method to this is using the reverse box method. But it's the same process, where I know this is x squared. That's going to be my a term. I know this is 10. So this first piece here is going to be x times x. That's the only way of getting an x squared. And I know there's going to be x's in this term. So what I'm looking for are two numbers here that are going to multiply to 10, but then when I add them together, they're going to equal 7. So in this case, it's kind of a guess and check thing, where I can say 10 and 1 or 2 and 5. Well, the only way I can get a 2x here times an x is this has to be a positive 2. And this has to be a positive 5 up here to get 5x. So now I can factor them into x plus 2 times x plus 5. This is more of a guess and check method if you know your multiplication and addition. And this is more of an algebraic way or a method. Our next example has a equals 1, b equals negative 8, and c equals a positive 7. Now, you'll notice that the b is negative, and the c is positive. Now, I'm looking for 7. In this case, it is only 1 and 7 that I can multiply together. But I need to get a negative 8. So when B is positive, or negative, and C is positive, these both have to be negatives. Because a negative 1 times a negative 1 is a positive 7, but when I add them together, it's a negative 8. So the trick is looking at the signs and figuring out what you need. So now I'm going to either replace those middle terms, or if you are realizing what is going to happen, I can jump right to my answer, which is x minus 1 times x minus 7. You'll notice that when there's a coefficient of 1, or the a is 1, I can jump from my factors right to my answer. Now, in this last example, the middle, the b is positive, and the c is negative. So I know that when I do my a equals 1, b equals 6, c equals negative 16, when I break down negative 16, one of those factors is going to be positive, and one of them is going to be negative. Now, what I do is I just list out all the ones that are going to multiply to a positive. And I look at the middle term, the b. If b is positive, that means that the bigger numbers have to be positive, and the smaller numbers are negative. If it was negative, then the bigger numbers would be negative, because that would be the result when I add it. So when I add these together, so I'm going to get negative 2 plus 8. I can then replace and then factor, or I can jump to my answer, and that is my final result. Now, these are all just practice problems, practicing those skills. So please complete those and then come in with any questions. The back page is actually where we have the solving. You'll notice that the directions before were just factor. The ones before were just expressions because they did not have an equal sign. For this one, it has an equal sign. So the first step is to get it equal to 0. So I'm going to subtract 7 on both sides. And I get x squared plus 6x minus 7 equals 0. Well, now I'm just, again, doing my a equals 1, b equals 6, c equals negative 7. You notice that from the previous example, we have that same result where the b is positive and the c is negative. So, I'm going to break down my negative 7, which is really just 7 and 1. I know that because b is positive, the 7 has to be positive, the 1 has to be negative, and I get my result here. So when I add those together, I would get 6. So then my factored form of this would be these two expressions. Now, the trick is it equals 0, so I need to know what x is. So like before, I would use the zero product property to split it, and I can say x would be negative 7, or x would be 1. Remember, I'm always going to have two results. And in the last question, it is just a word problem, but it gives you a formula that you will become accustomed to. And it gives the height h of rocket after t seconds when the initial velocity v is given in feet per second. Okay, so the rocket is fired with an initial velocity of 2,288 feet per second. How many seconds will it take for the rocket to reach a height of 6,720 feet. Well, I'm going to plug this stuff in. I then have to get it equal to 0. Now, what I'm going to do is I'm going to add the 16t squared and then subtract the 2,288t from both sides. So I get a grand result of So all I am doing with this is just rearranging it. Now, typically I do not work in these big numbers. So one thing that I do is that I can factor out common numbers, greatest common factor, before I actually factor out using the trinomial method. So you might not recognize this, but in this problem, all of these numbers are actually divisible by 16. So if I take a 16 out, I would be left with t squared minus 143t plus 420 equals 0. Now the fact that I factored out this 16 eliminates it. So now I'm just looking at this single equation, and I don't have to factor in the 16. And it means that the c, in this case, equals 420, and I can break that down. Now, I need it to add up to negative 143, so I know that both of them are going to be negative. So, I can start breaking it down into 2 and 210. Well, that's not going to work. Negative 3 and negative 140. Ooh. Once I get to this, I could keep going with this, like negative 4 and negative 105, but I notice that these two numbers are going to equal my middle term. So what I'm going to do is I'm going to stop what I'm doing. I'm going to use what works. So factoring this out, I'm going to get t minus 3 times t minus 140 equals 0. So therefore, t is going to be 3, or t is going to be 140. So you might ask yourself, well, t stands for seconds. So how can it be at 3 seconds and 140 seconds? So you have to take the question into consideration. We are looking for how long it will take to reach a height of 6,720 feet. Meaning that we're not asking when it hits the ground, we're asking when it's going to reach that height of 6,720. So if I make a quick graph of this, the rocket is going to come up and go back down in a parabolic motion. What happens is, I hit this level at 6,720 feet, and the rocket goes up it, goes past that height, and then comes back down. Well, how long did it take to reach that? It took 3 seconds to reach it the first time, and then 140 seconds to be coming back down and hit that height again. So you're always going to have that height twice. Now, the answer to this would be 3 seconds, because that's how long it takes to reach that height. But if they say, how many seconds will it be a height of 6,720 feet, then you're talking 2 answers. These are more practice problems. With that, please complete those and then come in with any questions. These are, again, basic skills. We're going to be doing application problems in class. So hopefully we will have met this objective and be applying these in class. Thank you.